Okay, I'm just gonna check that I am indeed live now. What we're gonna do is I need to be more focused on exploring jacks, so this is what we're gonna do. The way we're gonna do it is I do not know yet exactly what I'm gonna do, but I'm gonna try to explore. So um, I have this repository cd is it here where I have collected some random stuff, and I have been looking a bit at MNIST flow yesterday. It was in a collab somewhere. Mixture data classifier. I think I need to think about what I want to build. If I want to more like build something, or if I want to more like try to understand something. So I think a good idea could be to try to see if you could it seems there's always a mix between learning something a bit more from scratch or using something existing. I spent quite some time looking at whether it makes sense to do checks with language models, and apart from the Gamma code base, it's a bit sparse with nice repositories, and Hugging Face is also going away from their checks support and so on. And yeah, I think we just need to get into it. Just gonna see if it works. So on. And yeah, I think we just need to get into it. I think a good way could just be looking at papers, daily papers. A lot of this is very high level, like not so deep learning. don't know why I'm a bit unmotivated somehow. Cherry cake. I thought this was what Q star already did. So what they're saying is that we need to maybe just electric force grows with charge, and then you have thinking, so you have in kind of an unlimited domain of reasoning problems that you can now use. You can just say, I'm just going to predict the next token, and that's what I'm going to reason for. So electric force grows with charge. To determine the next token, we need to, let's think about this logic minds is using. The next part is going to be alternative, could be common phrase, perhaps wait, the entire text continue, alternative perhaps size. And I think some tokens are less important and so on, but I really thought this was what Q star already did, or what R star or whatever they called it. Prediction accuracy. It's a very sparse paper. There's not a lot of like stuff to engage with somehow. this is pretty interesting. It's also kind of doable to do something in this direction. So what they're saying is, as we generate tokens in our reasoning chains, we can look at the conditional distribution for the next tokens and compute the entropy for each. And then we see that it's very unevenly distributed. And then we see increasing the entropy. Because when you have a chain and you have high entropy here, if you then take a specific route, you take a specific path down the fork and you reinforce that, then you lose the other fork, and that is reducing the entropy of the policy in a sense. Yeah, that makes sense. RBR group relative. Do they mean specific types of tokens? I think they do. High entropy tokens often act as logical connectors, such as wait, however, unless. Thus also. I'm just confused if it's before or after. It's at the, okay. Yeah, if you have a high temperature, you get it. Sorry, if you have a high entropy, then you are going to be sampled differently, and then you figure 3. So you get better performance if you have a higher temperature.